Okay, guys, I'm going to start today's session. Yeah, hello everyone, and welcome. We are thrilled to have you join us for this special DJI webinar, where we will be exploring how DJI Dock 3 is driving the next wave of innovation in precision agriculture. So, we have packed today's 1 hour session with insights and real-world examples, all centered around how this technology is transforming the way we approach modern farming. The session is split into three key parts to give you a clear, structured view of both the tech and its practical impact. Firstly, I will kick things off with a deep dive into our latest release, DJI Dock 3. Now, I know some of you may already be familiar with the DJI Dock 3, but in this segment, I will be walking you through its key specifications, notable features, and a side-by-side comparison with Dock 2. Whether you have worked with Dock 2 before, or this is your first time looking into autonomous drone system, this breakdown will help you highlight what's new, what's improved, and what it means for agriculture operations. After that, I will pass the presentation to Sid from Polybee. Sid has working hands-on with drone solution in agriculture and horticulture, and he's here to show us how DJI Dock fits into smarter, more efficient, and increasingly autonomous farm workflows. And you will also hear some fascinating use cases from the field. And Sid, could you please just switch on your camera and say hi to the audience? Yeah, okay. And finally, we will open the floor for a Q&A session. So if you have any questions during the webinar, just feel free to drop the questions into the chat box on the top of the right. We will cover as many as we can before we wrap up. And thanks again for being here. Let's jump in and get started with the DJI Dock 3. So yeah, next slide. Yeah. So basically, we launched the Dock 1 in 2023. After 1 year, another improvement version has been released. It's the Dock 2, which is a completed upgrade of the Dock 1. And now the game changer Dock 3, a more intelligent and smart solution, will definitely change the real world. And next one. As you can see here, the new DJI Dock 3, a robust, intelligent, and mobile-ready docking solution that enables fully automated drone operations in some of the world's most demanding environments. So Dock 3 is built on our commitment to pushing boundaries in autonomous area workflows. Whether it's emergency response, infrastructure monitoring, or large-scale agriculture, Dock 3 is designed to rise to any challenge. So we will walk through the major upgrades in hardware design, deployment flexibility, signal performance, and how this innovation fits into critical use cases like the Australian agriculture. Yeah, let's just go to the next slide. So here is the comparison between the Dock 2 and Dock 3. You can see that the Dock 3 is a little bit heavier than the Dock 2, which is 55 kilograms, because we have improved the internal system like the cooling system. And also you can see that the size of the Dock 3 is between the Dock 1 and Dock 2 is a little bit smaller than the Dock 1 but larger than the Dock 2. And for the operating temperature, it has been improved from the minus 30 Celsius to 50 Celsius. And also for the IP rating, it has been upgraded to 56. And for the maximum, the allowable landing wind speed, it has also increased from 8 meters per second to 12 meters per second. Speaking of the charging time, it also has been reduced from the 32 minutes to 27 minutes. Yep, next one. And also you can see that the Dock 3 features several thoughtful upgrades that boost both reliability and user experience. So one notable change is the 8-degree tilt on the top cover. So this one helps prevent the buildup of freezing rain or dust, a small but crucial adjustment for long-term outdoor deployments in harsh environments. And also we have introduced a new sealing system, so which enhances the internal climate control, protecting sensitive components from moisture and extreme temperatures. So this upgrade also reduces the need for maintenance in remote sites. And also there is a new PoE port, specifically designed to support the RTK3 power supply, ensuring better integration with advanced positioning system. And we have also added a USB Type-C port, preparing Dock 3 for a future modular expansions and accessory upgrades. So another smart feature is the semi-transparent board, so which allows operators to view the internal status indicators at a glance without opening the unit. So on the exterior, so Dock 3 includes a redesigned base structure for enhanced stability during the deployment, especially important for vehicle or trailer mounted use cases, etc. And also, we have continued with a familiar and proven weather station design, enabling environmental monitoring with no learning curve. And the next one. And also you can see that the landing marks are clear and more visible, which pairs with our improved precision landing technology. And lastly, we have introduced a wireless charging module and support the cellular donk too, so ensuring better connectivity and charging efficiency in remote locations. All of these above features come together to make Dock 3 not only just smarter, but also more rugged and ready for real world operations. Yeah, and next one. And also, you can see that for all these upgrading improvements, the Dock 3 is able to master all environments. You can see that the Dock 3's API is up to like the 56, and also for the aircraft, the IP rating is up to like the 55. And just like what I mentioned previously, the wind resistance is up to 12 meters per second, and also you can see the temperature ranges is able you can is able to uh, work in minus 30 Celsius to 50 Celsius. And the next one, and you can see. Uh, We have also added the support for remote RTK calibration and level detection, allowing the teams to maintain, positional accuracy. This ensures both, safety and precision during autonomous mission. And for teams who covers wide areas and need rapid deployment, like agriculture, mining, or utility inspection, this features is a game changer. And speaking of the signal performance, so Dock 3 now includes, an external RTK module with a 2 dB signal gain, significantly improving the drone ability to achieve fast and reliable RTK convergence. And this is crucial for centimeter level positioning and for ensuring precision, mapping and navigation. And additionally, operators can install, the RTK3 relay at elevated positions, improving coverage in challenging terrains or complex environments. So basically, you can see that this allows more flexible, placement of the dock, avoiding, obstructions and enhancing signal quality even in remote and rugged areas. So all these upgrades combine to create a reliable RTK system that's faster to initialize and more resilient in the field. So you can see that the Dock 3 is truly a deploy anywhere solution. So thanks to its precision landing capabilities, and also by combining the SLAM technology with landing mark recognition. So the system ensures highly accurate and safe landing, even in cluttered or uneven deployment environments. So this matters more than ever in locations like farms, rooftops, or remote energy sites where terrain and visual interference might challenge conventional GPS only landings. So with SLAM and mark-based correction, the Doc 3 ensures that every landing is safe, repeatable, and accurate, even in environments that changes over time. So next one. So now let's just take a close look at a key opportunity area for Doc 3, the greenhouse farming, which is playing a growing role in Australian agriculture. So the Australian greenhouse market is currently, valued over like 3 billion US dollars, and is projected to nearly, double by 2030. So that kind of growth reflects, the increasing demand for high value crops like fruits, vegetables, and flowers, all of which, thrive under controlled environment agriculture. So most of the greenhouses across Australia are plastic-based structure. So they are quite lightweight, cost-effective, and quick to deploy. So making them, the preferred choice for many growers, especially in regional and remote areas. So by enabling like the multispectral data collection, John can pick up, a subtle sign of crop stress, things like, the pest outbreaks or water deficiency that the human eye might miss. So this kind of the, early detection is key to better crop health and yield optimization. So on top of that, Stock 3 automates, the flights, tasks like fertilizing and routine inspection. So which not only reduces, the labor cost, but also bring a whole new level of the consistency and efficiency in repeatable tasks. And whether it's a high tech, the glass house or just a simple plastic tunnel, Dock 3 enables growers to manage, operations with data-backed decision, automated workflow, and the minimum, manual effort. So as more, players enter the market, the integration of the tools like the Dock 3 into a horticulture and the greenhouse ecosystem will only accelerate, making food production smarter, more scalable, and more sustainable. And now I will hand over the presentation to Sid. Yep, Sid.
Thank you, Ruben. Hi, everyone. It's a pleasure to be presenting to you our work at Polybee using DJI's dot products and how we're creating value for the horticulture industry with it. So I'll go ahead and share my screen here. Okay, excellent. So, just a quick introduction on our company. So, Polybee is automating pollination and yield forecasting with drones and AI in the fresh produce sector. And our core objective of building this product is to reduce uncertainty in fresh produce agriculture. We strongly believe that what's between higher profits for growers and abundance for us as consumers is is a lot of uncertainty that they have to tackle every single day when it comes to decision making, right? And this uncertainty is all the more pronounced in fresh produce industry. And we believe that the way to get out of it is through automation and intelligence. So I'll speak more to that as to how we are unlocking higher profits for growers in today's webinar. Uh, Before that, just a quick introduction on the company. So I started this company about 5.5 years ago. My background is in aerial robotics and fluid mechanics. I was a researcher at the National University of Singapore, from where this company was spun out. And alongside me in the leadership team, I have my colleague Pankaj Malik, who's our vice president of commercial operations, has a long, and illustrious background in agriculture for more than 2 decades, has worked at some of the top companies in the space, and led their businesses regionally in Asia. And we're also quite lucky to have great advisors who are experts and have been leaders themselves in agriculture. For instance, Dr. John Purcell, who's been the head of R&D in vegetable seeds in Bayer Crop Science, and Jorge Herod, who himself also founded an automation company called Blue River Technology in the US, which was acquired by John Deere. Um, they're primarily a Singapore-based company, but now we just opened our office in Australia as well, in Melbourne. So very excited about our growth in that space. And we are backed by some of the most prestigious institutions in the region, including from Singapore as well as Australia. So, today I want to convince you all that DJ's Doc and Terra together have the potential to become the foremost and the leading platform for AI and automation in agriculture. And I'm saying this while being fully aware of DJ's existing products in agriculture, which is largely in spraying. But what I want to focus on today is about the untapped potential in agriculture for very specifically dog and Terra. I don't think there has ever been a time where we have had these capabilities of full automation when it comes to drone operations, where you can self-launch, self-recharge drones to collect high resolution data on the crops and use that for deriving the most important insights for farmers. We've talked about having drones for data collection and yield assessment and crop assessment for years and years. We haven't really seen it take off as much, and I believe the main reason has been that we have not had this ability to fully automate drone operations, which Doc now does, and it completely changes the course of how technology is going to shape up in this space, right? And we're very fortunate to be at the forefront of this, and we are very excited to show you what we've been doing with these two products. So a little bit a reflection on the opportunity in agriculture, I think it will be helpful for us because, again, kind of going back to what I said earlier, we believe that drones have a lot of potential, but we haven't realized it. Um, but let's first think about how big the potential is, right? And then we talk about how we are unlocking it. Um, you know, Agriculture is one of the foremost and most fundamental, industries for our modern civilization. And if you think about the total farm gate value of everything that we've grown today, crosses more than $4 trillion globally, right? So that's the value of everything that we grow and consume every single year. Um, and generally, it falls into three main categories. One is grain crops, so that's rice, wheat, corn, soybean, and so on, which helps satisfy our calorific needs, which is, of course, the first step in becoming a food secure civilization. But once we've done that, we need to start thinking about the other two buckets of crops in agriculture, which include fresh produce, which takes care of our micronutrition, and then other crops such as oil seeds and pulses and so on, right? Now, what's very exciting about the spread of crops is some of the sectors are growing immensely fast, and fresh produce is the fastest growing segment, right? Um, for example, in the last couple of decades, we've doubled the production of fruits and vegetables globally. Right? That's immense when it comes to an industry like agriculture, which is generally pretty slow moving in terms of growth. Now, the key thing here is that we have actually come a long way when it comes to penetration of technology in the grain crop sector, where commodity crops are quite homogeneous. We have increased productivity there immensely in the last decade, and we've done very well to reduce uncertainty in the cultivation of those crops, right? But the problem remains quite existential when it comes to uncertainty for fresh produce farmers who typically have comparatively smaller operations. The kinds of crops that they grow are perishable, and they're quite finicky as well, right? They have very specific requirements for growth. And all the fresh produce that we consume, everything that we see in the fresh produce section of our supermarket shelves, um, is something that is, the fruit of labor for farmers, and they have overcome a lot of difficulty in that. One of the main reasons for that is also, beyond what I said earlier about the crops being generally finicky, is also that we have not invested as much when it comes to technology, in this space, right? Because the priority has always been grain crops, which has seen a lot of scale, a lot of mechanization, a lot of automation, but we haven't seen any of that as much in the fresh produce sector, and that's why we feel this is an exciting space to dive into, right? But one last point I want to make in terms of potential is that because it's growing so fast, um, it's helpful to kind of reflect on how big this space could be. For example, if everyone consumed sufficient fruits and vegetables as is necessary for our health and having a perfectly balanced diet, um, we would have to grow at least twice as much fresh produce in order to satisfy that, which would mean a couple of trillion dollars worth of farm gate value. And we cannot unlock that by just growing on more area of land, right? We have to get technology to improve productivity as well, right? And that's where our whole effort comes in as well. Now, let's kind of zoom into what are the problems that we're solving in fresh produce with our technology using DJI products as well. And maybe a little bit of a heads up there is on, generally speaking, how to think about increasing productivity when it comes to fresh produce crops, right? So crop production, can be seen from the lens of an analogy, which I often like to refer to, which is that, plants can be thought of as bioreactors, right? They take inputs such as energy, nutrients, and water. And, if the temperature and humidity conditions are appropriate, the bioreactor's reaction will start and it will run at a certain speed, right? Now, more specifically for fresh fruits and vegetable crops, there is another process that needs input, which is pollination, right? And that maybe is applicable to at least half of the crops that we grow in fresh produce, if not all. And one of the things is that pollination has largely been left to chance, right? Because we rely on natural pollinators that are wild animals, even if they're domesticated. Um, and we don't have control on their behavior, right? Which means that we're leaving pollination um, to chance, and there often ends up being a lot of uncertainty as a result, right? Now, we almost entirely depend on bees and insects for it, even if these are managed hives, and therefore, you may not have optimal results in pollination when you need them, right? Now, with all the produce that we've made in agriculture, there is some control that we have gained on the inputs, right? So, for example, if you're growing in a greenhouse, you can have more control on nutrients, water, chemical inputs, energy, maybe to some degree because you can't fully control weather still. But greenhouses have made it a lot more manageable. But one piece that still remains unaddressed in terms of inputs is pollination, right? So that's on the input side of your bioreactor. Then on the other hand, um, we have to close the feedback loop, right? Like just the way bioreactors have a feedback controller, plants should work the same. And a feedback controller cannot do its job unless it has sensing, right, based on which it can actuate. Um, and in today's agriculture, this piece of sensing is completely missing, right? We do not have any idea on what the state of the plant is in objective digital terms, right? So we don't know what the yield is like, how it's growing, what the nutrition stress is like, what if there's any pest or disease pressure on the crop. We have absolutely no idea of any of this. And think about it, the whole of agriculture runs this way, right? So we've come pretty far without having this fundamental piece in place. But think about the potential that there is to unlock if we solve for this ability to measure the state of the plant at a high enough level of resolution, right? It can't be too cursory where you have an idea of that, okay, this whole farm is not doing well. You need to be more precise than that. You need to get to the level of every single plant, right? Ideally. So that's the missing piece in agriculture that we're solving for. And in order to do that, what we're building is a digital ecosystem on the top of DJ Enterprise products to gather these insights and get more control on some of the inputs, such as pollination, and solve for that missing piece of sensing on what's going on the plant level, right? And that is coming through some of the features that we have, such as measuring plant stress, measuring the growth rate, and forecasting yield for farmers, right? If we answer these questions for farmers as to when they're expecting their yields to be harvested, what is the growth rate of the crops, what are the stressed areas, we are transforming their business. We are probably turning them into a much more profitable business just by answering these questions. They don't need to do anything differently in terms of how they operate. It's just about um, knowing what's happening at the right place at the right time and then steering their strategies and operations according to it, right? So that's our goal here, right? We want to solve for those missing pieces where you're not able to measure the state of the plant and you have more control on certain inputs that are important, such as pollination. And we strongly believe this can be fully achieved with a product like Doc and put it together with DJI Terra. You can have a strong foundation to build great AI products, which will help you get some of these insights, such as plant stress, growth, and yield forecasting. Right now, I just want to quickly walk you through some of our examples. Right, let's start with pollination. So we're currently using our technology for two crops grown in greenhouses. The two crops are tomatoes and strawberries, and we're also investigating blueberries. The regions in which we're active are Australia, United Kingdom, and we also have some interest from the Americas, especially from Mexico and Canada for this product. But the most important market for this so far has been Australia, because if you think about greenhouse agriculture in Australia, pollination is a huge problem and a huge burden for growers. The main reason for that is you do not have bumblebees in the mainland continent, and you cannot import them either because they pose a threat to the biosecurity of the region. So all pollination has to be done manually, right? So you can imagine how huge a burden it is for farmers who want to get into greenhouse agriculture, or those who are already operating in that space. So I want to show an example of how we have put together our product, right? So what we've done is we've built an autonomous navigation software using SDKs made available by DJI Enterprise, such as, for example, Cloud API and others. We leverage those existing provisions, and we build a lot of software on the top of that to manage the fleet of drones that can self-launch and self-recharge as and when necessary, right? So here's an example of our deployment in a strawberry farm where we're using Dock to do autonomous pollination as well as yield forecasting, right? These are the two applications that we're going to look at right now, where whenever the microclimatic conditions are right for pollination, the drone self-launches based on our navigation software stack that communicates with Cloud API and does the rest. And once the drone is launched, it finds its way to the right greenhouse, and then it moves on towards conducting pollination flights. So here's what we're looking at as an example. Um, so when pollination is going on, essentially what's happening is the drone is flying over these rows of plants, right? And as it flies over these rows of plants, the airflow from the drone's propellers vibrates the flowers at just the right frequencies. Um, so maybe here's where it will be helpful to have a quick, so to speak, plant biology lesson. Maybe I'm taking some of you back to high school days. Um, but you know, here's how the pollination method works, where the airflow from the drone's propellers vibrates the flowers at just the right frequencies for successful pollination, right? And this airflow is specifically engineered for two crops right now, that is strawberries and tomatoes. And the way pollination works here is that it is classified into two main types: self-pollination and cross-pollination. Um, if the male and female parts of the flower are on the same flower, we call it self-pollination. If they're on different flowers or different plants, we call it cross-pollination. Right? The crops that are grown in greenhouses are all self-pollinating, which means you don't need to transfer pollen from flower A to flower B or plant A to plant B. uh, Pollination can be done within the same flower. All you need is a mechanism to vibrate the flowers at just the right frequencies for successful pollination, right? And that is exactly what we're doing by utilizing the airflow from the crop wash, that is, right beneath the drone's propellers. Now, one could, ask a question here, right? Like, what's stopping us from just using any drone or even any kind of a fan or a ventilation mechanism to vibrate these flowers, right? And that's where our kind of, proprietary knowledge comes in when it comes to what is that relationship between airflow, motion on flowers, and how that motion on flower leads to successful pollination, right? So, um, that is at the core of our IP, which we call aerodynamically controlled pollination. think of it as a function which takes certain inputs, that is, what crop we want to pollinate, what drone we're using, what is the propeller size of these drones. And with these inputs, it comes out with a flight plan, and what height the drones need to fly at and how fast the drone needs to fly. All of this has been determined based on a lot of research that we've done on pollination. We've done a lot of experimental work wherein we studied what sort of airflow, what intensity, what speed would lead to certain amount of turbulence and vibration of flowers, and how does that change from one type of crop to another. So we have that kind of quote unquote lookup table, which is our proprietary knowledge, and we leverage that to use any off-the-shelf drone. We could, of course, there's a certain range of drones that you can use. Maybe some drones are too small or some are too big, but there's a sweet spot which is big enough, right? And luckily, the dock drones do fall into that sweet spot. So we take that as our starting point. We come out with a flight plan, and that is what makes sure that when these drones fly on the top of these flowers, pollination will be quite likely successful, right? So that's our approach. Um, and then, when the drones are flying for pollination, we're also leveraging the highly sophisticated cameras on board the dock, where we collect RGB, images on the adjacent rows of crops, right? And this is for the purpose of, deriving certain yield metrics that are important for growers, right? And these yield metrics include fruit size, fruit count, and distribution of fruits across those two variables, and ripeness of fruit as well, and how it's going to change as a function of time to be able to forecast it, right? And how we are doing these metrics is by using these high resolution images coming off from the drone's camera, and then we use our proprietary AI and computer vision pipelines to build 3D models of the crop, right? Now, one could also argue and say, hey, can we use GI Terra here? You could. It's just that Terra currently is, largely requiring a user interface. So we want to pipeline this whole process, which is why we're using some of our other methods. But yes, in principle, you could use it. And once you've built a highly precise and accurate 3D model of the crop, then you have the opportunity to um, closely track every single fruit, right? For example, in strawberries, we are able to then use more layers of technology that we've built in 3D tracking, which allows to precisely count fruits, size them, classify them based on ripeness, and that gives growers the most accurate possible estimate on what kind of yield they have, right? Think of it like having a very precise inventory check, right? So that you are able to make much better decisions on the top of that, where you can plan your labor for harvest. You can, make decisions in terms of pricing your produce if you have that opportunity, if you're a big enough a grower, and that is where we can help pull levers when it comes to improving profits for growers, right? So this is a critical piece, because one of the key hurdles right now for growers is, okay, there's this capability of computer vision and AI which we have built, but that alone is not enough, right? Because you need that high quality data consistently a certain way, which is very hard to get right if you have people collecting this data with cameras, right? Even if it's mounted on a vehicle, or even if there's just a walking, and trust us, we've tried that, it doesn't work as well. This is where doc is a game changer, which allows you to automate this whole process. It allows you to also perform other tasks at the same time, such as pollination. So, kind of going back to my earlier point, we're able to build this whole digital ecosystem for farmers using doc, right? So doc is the backbone of it. There's many more layers of application we have to build on it, but it's all kind of built on the top of the capabilities of doc. And we've managed to get this product out there live. So currently we're live in Australia, we're live in the UK, and we have received great feedback from our customers in the greenhouse space. Right. So currently we're just kind of we're incorporating some of the more recent updates to the firmware that we have received in dock, which actually allows us to use the dock now, not just in tunnels but also glass houses. So we're working closely with some of our customers in the glass house space to launch this product in their environments, which we're extremely excited about. It's been a long time coming. We're quite grateful to DJI for having rolled out some of those recent updates which allow us to use Doc in those environments. Um, so yeah, maybe just a quick reflection on yield forecasting, generally kind of more of a recap of what I already said, which is what we do is we use Doc to collect data at a high resolution and high frequency. Um, with that, we use our computer vision and AI capabilities to perform certain key measurements on plants. That is our proprietary technology. We understand its relationship with the microclimate and its forecast, and that put together allows us to answer two simple questions for growers, which is when is the best time to harvest and how much volume we're expecting in that harvest, right? And with that, they're able to make better decisions on planning their labor, planning logistics and packaging, and pricing their product. Now, I've talked a lot about greenhouse, but before I wrap up, I just also want to reflect the work that we're doing with Doc in open field agriculture, right? This is because, again, kind of going back to my earlier point, we're more, kind of obsessed about serving the fresh produce space, which is not just greenhouses. Greenhouses are very attractive in some ways because it's high value produce, number one. Number two is production is longer in terms of the duration in the year. And number three is also that with a product like Dock, it's much easier to get approvals, because all of that is indoors, it's within line of sight. So you're not technically doing beyond visual line of sight flights. So all of that makes it very attractive. But there's such a huge opportunity in open field horticulture as well, in certain fresh produce crops. So I want to walk you through two examples here where we're using the exact same technology stack of using Dock for autonomous data collection and computer vision and AI to extract certain plant measurements to help forecast yield for farmers, right? First example I want to show you is spinach, where we're using Dock to collect data on the crop, where it's a very straightforward application of Dock where we have certain flights planned. These are largely oblique flights to build a digital surface model of the farm, very low altitude flights for high resolution. And with that, we are then able to use our AI models on the top of it, where from the DSM, we use our AI models to detect leaves of spinach, and we precisely measure the size of leaves of spinach. Now, why are we doing this? Because if you think about spinach as a crop, um, the big decision for farmers to make every single day is when to harvest. And that's because the majority of the market in spinach is baby leaf spinach, which means the leaves have to be in a certain size range, right? For example, it has to be somewhere between 10 to 12 centimeters, right? If it's anything more than 12 centimeters, retailers can reject the whole shipment from the growers. But on the other hand, growers only get paid for the kilograms that they sell, right? So it's a fine balance for them to strike where they need to decide when to harvest such that they're maximizing their yield per unit area. So they're getting as many kilograms from their farms as possible, but they're also not exceeding the spec range that has been defined by the retailers. So how do you strike this fine balance? Well, there's no other option but to go measure the size of leaves, right? And right now they have never had any product which helps them do this. Farmers have been walking the rows and they've been just using their own judgment, their hunch to try and decide, okay, what's the best time to harvest? But now we're enabling them with this highly precise, product where they can actually measure leaf size. They can project the size of leaves ahead of time as well based on the weather forecast, and they can make decisions in advance. They're not reactive. They're proactive. They're on the front foot, and they're able to improve their profitability by making these decisions way more efficiently, right? So this is what's actually happening at a leaf level, where from the DSM that we generate, taken using images from the dock, we use our proprietary AI models to detect these leaves, and that's the level of precision we operate with. And every single leaf is constructed in 3D, and we're sizing it very precisely. And based on that information, we give these metrics to farmers, where we tell them what the leaf size is, what the forecast of the leaf size is going to be based on weather conditions. Um, and then on the side, we're also, by the way, using multispectral imaging to detect stress levels, right? And that, of course, is not in dock yet. We wish that changes, and we'd love to have a dock with multispectral drones, with multispectral cameras. But for now, we're using M3M on the side as well because there's such a huge demand from farmers to be able to have a level of intelligence on plant stress so that again they're not reactive but more proactive. And I'll tell you an example of show you an example of why it is so and why they're so excited about multispectral imaging, especially in a crop like high value crop like spinach. where we've done a lot of case studies where we've been able to detect stress on the top of the multispectral images using our AI models, where we can see hotspots much faster and we can see them deteriorate in time. Um, and all of this is happening much earlier than you could see it in the visible spectrum, right? Here's an example where you had a stressed hotspot, which was already visible on the 26th of October, um, and it only deteriorated as a function of time. But in the RGB spectrum, it looked pretty okay, to begin with. And by the time you found out, you're already lost almost more than 2 weeks, right? So that's the level of value we can bring to growers if we have multispectral cameras looking at their crop very regularly. Currently, it's only M3M that has the multispectral camera in the DJI suite of products, but you know, I see immense potential. I cannot stress that enough. If you had a multispectral, camera sensor on the top, because then you have a one-stop shop, right? All a farmer needs is a dog, right? It's the equivalent of having a tractor. I think any self-respecting farmer in the future, 10 years from now, should look at having a dock, with the same level of importance as they do, when it comes to having tractors, right, or any autonomous equipment or any mechanization equipment. That should be a part of their, fundamental assets to run their business. And I think having a multi-spectral drone will be a huge, huge push in that direction. Another crop that we work on is broccoli, where we do stand counts of the plants. We measure the size of heads of broccoli to help time the harvest. Just like spinach, broccoli heads have to be harvested at a certain time. There's a sweet spot in terms of size, and the harvest have to be timed very precisely. So we are able to do stand count with dot plus multispectral, which helps us improve the accuracy a little bit better. We do head size distribution purely using dock, and then we project the rate of growth ahead of time, just the way we do for spinach. And this is the level of precision that we operate with, where every single broccoli head, is detected, its size is measured, and then we, create a distribution chart, which helps growers decide, okay, if my sweet spot is between 12 to 40 centimeters, I should go harvest today, right? Or I'm expecting the peak to be in that range 2 days later, I should plan my harvest then, right? So you cut down on your harvest passes. You don't have to send your crew unnecessarily for too many times, and that's a huge, huge gain when it comes to lowering the cost of your production, right? Um, Maybe just to kind of towards getting wrapping up towards the end of our webinar, I just want to highlight why it is that doc is such a great prospect, not just for farmers, but also as a use case, from DJ Enterprise's perspective, or for our ecosystem's perspective, right? Because um, on the one hand, for the customers, it's the ideal product because of its autonomy, its ability to dock and recharge, autonomously as well. And that has, I think, completely changed the game, and it has unlocked immense potential for use case of drones in agriculture in general. On the top of that, why it's a great opportunity is it allows players like us and ecosystem players to build apps and products on the top of what Doc and Terra have to offer, where you, with your AI models running on the top of this data set, you can deliver metrics with very high precision and accuracy to your end users. And when it comes to just the whole ecosystem's perspective, what's great about drones in agriculture is the utilization rate is extremely high. You cannot, especially in fresh produce, by the way, because the plants are growing almost year round. Even if there are seasons for certain crops, big producers make sure that they have year-round supply. So there'll be times when they grow in one part of a region, and then in winters they'll go to another part, which is not super far. But the utilization rate is throughout the year. They need these insights every ever so often. For example, we do data collection every other day with every single customer, right? And when the drones are out there, spending a lot of time flying because we need high resolution imaging, which means the drones have to fly at least 4 to 5 hours every single day. Think about that, right? So very high utilization rate throughout the year, which is in everyone's interest. So that's why we believe agriculture is such an exciting space for dog. And maybe just to wrap up, a little bit more about what we've achieved so far. So our product is not just at a concept stage. We've proven the ROI with some of the biggest players in Australia and New Zealand, and they have seen gains for themselves through either of these four categories in the form of labor savings, higher yield, savings on inputs, and data-driven pricing to get more out of the same amount of crop, right, when it comes to your profitability. So yeah, we're very excited about what's to come in the coming years, not just in Australia and New Zealand, but globally as well. When it comes to our business model as a player in the space, of course, we use off-the-shelf DJI products. We build all our software on the top of it, and based on what specific service we are providing, be it pollination or yield forecasting, um, we charge our customers per hectare per year. And maybe one last point, just want to highlight how big the potential is for dogs in agriculture. So, for example, if you go by how we have been using drones with our early customers, and these numbers are, of course, bound to change, but I think the takeaway here is the orders of magnitude when it comes to what the potential is for number of unit sales for the types of use cases that we are doing. When it comes to greenhouses for pollination, we've been using about 5 drones per 1 hectare of a glasshouse. And if you look at the total area of glasshouse cultivation for crops like strawberries and tomatoes globally, it's of the order of 25,000 hectares, right? So if you are using 5 drones per hectare, you can imagine what the potential there is for these two crops when it comes to greenhouse applications. When it comes to open field, still huge, huge, huge potential. Where if you just look at the three crops that we've been working on, spinach, broccoli, and lettuce, all put together, the total area exceeds 500,000 in terms of hectares in certain strategic regions, not just all over the world, but strategic regions like let's say ANZ and Americas. Um, we're using one dock per 20 hectares, and that in itself is a potential of 20 or 30,000 units, globally, right? So there's absolutely no dearth of opportunity when it comes to selling docks in this space. And that's why we are hoping that the whole industry rallies and starts exploring use cases with dock in agriculture. So that brings me to the end of my presentation. Thank you so much for your attention, and I'd be quite happy to take any questions.
Yeah, okay. Okay, thank you, Sid. So let's just move to the Q&A session. And I can see there is few interesting question listed here. So the first question, I think Sid, you are able to answer it. Is Polybee's solution seems quite sophisticated. It seems like not all dealers can directly sell dogs to end users because your solution in agriculture requires AI built by Polybee. Is there any way dealers can collaborate with Polybee?
Yep, absolutely. I think that's an excellent question to think about. If anything, we are actually seeking those partnerships and collaborations because, for us, our core strength lies in the software that we build on the top of, DJI's products, right? So that could be for the fleet management, that could be for the AI and computer vision that we do on the crops. So that's our core strength, that's our core capability. And if we want to realize the kind of potential that I talked about, which is tens of thousands of drones globally, we're not going to be able to do that by ourselves, right? So we are openly seeking partnerships with dealers where you could help us get to more customers globally, right? Where let's say if we have identified certain key customers, we would love to work with dealers who can help us onboard the product with our new customers, who can help service our new customers, and the sale of drones can come from the dealers to our end customers, right? So that's a mechanism where we see a win-win for both parties, where Polybee gets to service more and more customers globally without having any big overheads. Dealers get to unlock a new blue ocean opportunity, which is agriculture. We haven't really seen a lot of dock use cases yet, but that's what we're here to change, right? And we would love to unlock that avenue for dealers by allowing them to work with us and our customers to sell their dock in this entirely new space, and we'd love to hear more from any leaders who might be interested in doing so.
Okay, I can say, yeah. Another question is how the Polybase service will be applied for palm plantation.
A palm plantation, is that right?
Yeah,
Okay, got it. So that's an interesting space. I think we have looked into it very early on in our journey. Um, the key question there is what kind of insights or intelligence are a palm oil operator is looking for. For example, it could be something as simple as, can we have a count of the palm trees, right? Can we have a sense on their stage of development? Can we have a sense on the uniformity, right? Can we detect any early stress on these plantations? I think if those are the use cases, then our capabilities can entirely transfer there. For example, again, it's an open field use case, so using Doc is very straightforward. Then the question is, what are the insights that the customers are looking for? If it is about counting the number of palm trees, then we can quickly build an AI model to do so, which is very straightforward in my view. If it's about detecting stress early on, then I think we'll have to stick to multispectral imaging, which won't be applicable with dog. But the good news is that you usually don't need very, very high resolution with multispec, so you can do flights at a higher altitude, even if it has to be done manually. So there's that. And then the other question could be, are there any other agronomic insights that we can try to gather from just RGB images where doc can be used? So, definitely we are keen to learn more. What are the key insights that operators are looking for? But I do see that doc can be a very appropriate here, largely because how big the plantations are, right? So you need to collect a ton of data, which is very hard to do with manual flights. So I think doc can be a game changer there.
Okay, thank you, Sid. And another question is, uh, let me see. The market potential for multispectral imaging seems huge. We have not seen any companies provide insights the way Polybee does to high-value produce growers. How do you get your users operate both DOC and M3M?
Yeah, that's such an important question right now for us because the value that comes from the insights that we get through RGB images and multispectral images is quite independent of each other, right? So those are two completely different streams of value for our end users. Um, the main reason why we've been going ahead with both applications is because, again, there's that sort of nature of compounding value. When all of this information is coming together, the sum is greater than the parts, right? When it comes to how growers are able to use it. Um, Currently, dock operations are obviously autonomous, so it's pretty, now we've come to a stage where we have an SOP. It's easy to set up and onboard our users. But when it comes to multispectral, um, unfortunately, they do have to do the manual flights still. So we have to train them on what is the flight schedule, how often they should do the flights for stress detection. They also have to transfer the data from the drone to a local workstation where we can start our processing pipeline uh, to take it from there. So that is a little bit of a pain point for our customers still, where they have to do the manual flights with the multispectral drone. But we're hoping that as the momentum grows with the docks use case in agriculture, multispectral dock becomes a viable option. You know, and if we get there someday, I think that will solve all problems.
Okay. So the next one is what is the outlook for broader horticulture, for instance, tree crops in terms of pollination, yield estimating, etc. Is there a chance for pollination with cross-pollinating crops?
Yeah, very good question. I'll break it down into two parts. One is about pollination, the other is about yield forecasting when it comes to orchard crops, right, or tree crops. So if you think about pollination, that's a trickier question because when it comes to cross-pollinating, crops, it has more steps involved in it, such as step one is to first harvest pollen from the male flowers or male trees, right? That process is very hard to automate because you're literally looking to go collect the flowers and extract the pollen from them. It's also a very delicate process, so you can't be very brute force about it in terms of mechanization. So the key question is, can we automate or can we reduce the cost of pollen collection? Maybe some growers might actually say, yes, we would rather do that, right? We'd rather have maybe people harvesting the pollen from the male trees, and we can store that pollen, right? Um, if that means increasing yield by 20, 30, 40%, then by all means, we're willing to do it. So that's a possibility, but I'm just saying that there's a step involved, which is collecting the pollen, right? Second step is storing it, which again, uh, I wouldn't say that's um, That's an unsolved problem. I think there's ways to do that. We'll have to see which crop we're talking about. Maybe some crops are a little more straightforward in terms of how to store pollen for long periods of time in cold storage. And if that is already known, then great, not an issue to worry about. And then the last step is pollen delivery, right? I think that's where the key question is, how far can drones go in terms of enhancement? Because one of the key elements of cross-pollination is also the timing. It's not just about the delivery, right? You have to deliver the pollen at the right place at the right time, depending on the microclimatic conditions. So I think I see a lot of potential there for drones to do that job well. The key question is Dock the right, product for it? I'm not sure because pollen is pretty heavy in terms of payload. You need to carry it and deliver it. There could be some existing DJ agriculture drones that might be better suited for it. The challenge there is going to be recharging, so you'll have shorter flight times and someone would have to keep swapping batteries. But I think that there is that potential with agriculture drones for cross-pollinating crops when it comes to pollination, right, for delivery. So that's for pollination. Then the other question is about yield forecasting. Yes, absolutely. I think there's huge potential with dock. We're already looking into some tree crops, such as apple, citrus. We have a request on summer fruits as well from Australia. So we haven't actively started deploying yet, but we have a very close eye on orchard crops for yield forecasting. And the main reason is whatever I said earlier about the advantage of using Doc and computer vision and AI applies equally well. So you can use Doc to acquire data autonomously and continuously. And then we can use our AI and computer vision capabilities to count fruits, size them, classify them based on ripeness, and all of that information will make decision making much more streamlined for customers.
Okay, good. I think we can have like two more questions. So, if we are interested in pollination or pest infection, is it possible to detect that using drone imagery? What type of agronomic information do we need?
Um, it's a bit hard to answer that question without having a specific crop in mind, because plant infections and, let's say, pest and disease pressure look very different from one crop to another, especially in horticulture or fresh produce. So it's a bit difficult to answer that question generally, but I think it's best to have a conversation with a potential customer who's asking for it and see if that's something that is a sizable market as a crop. What is the nature of stress that they experience with that crop? And can you detect that stress in the multispectral region? And if answers to those questions is yes, then I think that's a valuable pursuit.
Okay, I think the last question would be how do you integrate Terra into your workflow?
Oh yeah, great question. So currently Terra is only UI based. So we use Terra for development purposes, where we're, let's say, working on a new crop or we're looking at testing um, some of our features or new or working on new experiments, so to speak, where we need a quick turnaround on the data and the insights. In those cases, we use Terra still. Um, I think to fully integrate Terra into a workflow, we would need there's the Stereo API as well, right? So that's one option. The main reason why we haven't used it yet is because in horticulture, the data that you collect from drones tends to be pretty big in size of or memory. So it's a lot of time that is needed to upload the whole raw data set to cloud, and then you miss out on the turnaround time for your customers, right? Which is not something you'd want. So what we're hoping that maybe sometime down the line there's a use case for a Terra SDK, so to speak, where you can run that whole reconstruction locally. So you got a lot of raw data, let's say 20, 30 gigs worth of raw data. You use a Terra SDK module to already reconstruct that locally to maybe a few gigabytes from 20, 30 gigabytes. And then it's easier to upload that reconstructed file, that ortho file, to cloud because it's just a couple of gigs. And then you can run your workflow on cloud thereafter. So currently, because there's no Terra SDK, we're not able to fully integrate that into our workflow, but we still use Terra for our R&D and development purposes.
Okay, thank you guys. I can see there are few questions live there. So due to the time limitation, Probably we are unable to answer all the questions one by one. But if you are interested in this topic, just feel free to reach out to us, and we are happy to answer the questions through the correspondence. And thanks again. Thank you guys for your attending, and have a nice day. Yep. See you
Thank you,
guys.
everyone.